All right. Welcome, everybody. My name is Manasi, Vartak, and I'm the CEO of Verta. Super excited to be hosting this panel to cap off the third Verta MLOps Salon. This time it's focused on applying MLOps at scale. And we have a fantastic panel of guests today, including Adam from Finastra, Hien from DoorDash, and Stefan from Stitch Fix. And we are going to be covering off a set of questions, including org structure for data science, what does scalability mean, MLOps monitoring, a whole gamut. So to kick it off, if I could ask our panelists to provide just a brief intro for folks who might have missed the earlier sessions before we get started, that would be awesome. And Adam, if you could kick us off, please.
Yeah. Hey, guys, I'm Adam Lieberman. I'm the head of artificial intelligence and machine learning at Finastra. I work together with my data science organization to build many different data science solutions across our many lines of financial business.
Hi, I'm Stefan Krawczyk. I lead the model lifecycle team under data platform at Stitch Fix. And essentially, my team's mission is to streamline model productionization for data scientists.
Cool. And my name is Hien Liu, and I lead the ML platform team at DoorDash. And yeah, so we try to help data scientists be as productive as possible.
Fabulous. So maybe the next question, which is, what does MLOps mean for you in your organization, going off of the intros I just heard? In any order, please feel free to jump in.
I can give a quick start. I've been reading up a lot about MLOps, and it's very fascinating to see different definitions from various sites and so on. But to me, it's just essentially about combining good software engineering with DevOps, but in the realm of building, deploying, and monitoring ML systems. So that's what MLOps to me is at a high level.
I think going off of that, yeah, definitely operationalizing your model, knowing what's going on with it, where it's performing well, what's going wrong with it, knowing the current state of it is a big thing for us.
Yep, yeah, echoing similar kind of words. So how can we productionize and operationalize making machine learning models and getting them to production while providing all the software engineering, DevOps best practices along the way?
Perfect. So when you think about the goal or the mission that your teams are serving, how do you generally quantify the business impact of these teams? Is it models pushed to prod? Is it revenue brought in? Kind of, if you could talk through that.
Yeah, I would say from my point of view, we think about revenue, ROI. One of our big areas is innovation. Can we build models that are going to break through and push boundaries? Maybe it's a proof of concept model or a beta API that we deploy, but really, what is something new and thoughtful that we can bring to our customers?
Yeah, I mean, as a platform team, I want to say, business impact is a little kind of second order because we're trying to help people who will impact the business, and so actually coming up with metrics is somewhat difficult. So number of models is a good leading indicator, but is that really a good thing to judge things by? And so what we really and then given that our domain is so broad in terms of what data scientists we support, we can't really measure their effectiveness because everyone's doing different models that might take different speeds, et cetera. And so what we end up really kind of relying on is, one, do we make them successful? So do they want to keep using us? So is their net promoter score good for us? And then what coverage do we have of the department? So of the people who are creating models, how can we kind of incrementally get more and more adoption of people to use our tools? And so through that, as long as we can make them successful and they want to use us, we will have kind of business impact.
Yeah, very similar with that. With DoorDash, we very, I guess, impact-driven kind of a company. So we do keep an eye, very close eye on what kind of use cases we're enabling or making an impact on. But it's hard for us to justify the dollar amount because we're just enabling, like Stefan was saying. But there's some other metrics that we use. For example, the adoptions, like Stefan said. And if we continue to see the adoption, the number of models keep increasing, the number of features being used more and more, I think that's a good sign of the models being useful to the rest of the company.
Got it. Yeah, it's like the databases team that's supporting all the queries that you might be running on your website. That's very fair. So we have titled the Salon this time as MLOps at scale, and scale can take different forms, whether it's throughput, latency, I don't know, whatever scale means for you folks. So if you could talk about what it means in your particular organization, I think that'd be a great perspective for the audience.
Sure. I mean, I can start this one. So, ML at scale, kind of at Stitch Fix for us, kind of means we have 145 plus data scientists who are doing very different modeling things. So at scale for us is partly an organizational thing. Since we have so many people doing so many things, how can we ensure that one, if they're not stepping on each other's toes, two, they can kind of reuse things, and three, that like there isn't any we have introspectability and knowledge about the entire system such that pinpointing things is easy, or if someone leaves, it's very easy for someone to come in and kind of take over their stuff. So looking at the human aspects of scale here, of like people doing stuff is a big aspect of us. So how do you curate models? If you have 10 models on your team that have been running and you're iterating, how do you kind of ensure that the visibility and monitoring or the things are there for them to kind of enable scaling and managing more models as time goes on? That's the other side of things that we're looking at. Otherwise, it's not really requests served or requests per second. That's not really kind of scale for us. It's mainly on a lot of people doing a lot of different things, and how can we make that manageable?
Yeah, I would say for us, when I think in terms of scale, we work with a lot of different financial institutions. And it's really, how do we deploy these models for all these different financial institutions? I think, looking at some of our lines of business, it's very hard to build, one generic model, just because, if you have 3,500 different clients, they all have different sets of data, the data changes very drastically, but they all want one kind of model. And we have to build these tailored models. How do we deploy, 1,000 different models so that we don't have to inspect one by one or build one model by hand and put a data scientist for each client? So it's really kind of a big model problem for us.
Very fascinating to hear the scale means something differently for different companies. And I think just to add to that, because DoorDash is an e-commerce company, so the request volume, the latency is very important at our company in terms of search and recommendations. So we need to be able to support up to millions of predictions per second for all those use cases. But I also want to echo what Stefan was saying. As the company grows, there's going to be more and more models. How do we scale on that aspect as well, in addition to being an online prediction use cases?
That makes sense. One question that actually we took up in a previous Salon was sharing information about models, as there's more people building models, different kinds of models and all of that. Curious about if any of you have best practices or things that you've done to share knowledge, or just this model exists, this is how to use it type of information in the org.
I can share at DoorDash, we actually try to limit the number of model types that data scientists can build.
Interesting.
Because we prioritize able to support data scientists deeply by not saying we're going to support all kinds of models, right? So, but we still want to able to support most of the use cases that are needed at DoorDash. So we support both PyTorch and LGBM. So tree-based versus PyTorch that cover most of the use cases here. So we don't want to say we will support TensorFlow, we don't support other frameworks at the moment. So it's very intentional in terms of what we want to support.
That's fascinating. Yeah, I remember Twitter, we decided a long time ago at that point only support TensorFlow because the system was super scalable if you use that, and the other stuff was just no-go. But I'm sure it has extended a lot since then. For Stefan or Adam, where people are building different kinds of models or models per customer, how do you share information about models?
Yeah, from our standpoint, we have a model registry. So we're logging, the different performance metrics around our models, the training data sets and validation data sets. We have our use cases in there. You can see kind of the cluster that's connected to and the dependencies. So if we have, product teams and maybe they have, a software engineer that wants to take a peek at our model, we can point them to our model registry. And from there, you'll be able to see which data scientists are working in what notebooks for those models.
Yeah. So we've been kind of building that with the model envelope, or at least that's kind of backs our registry. In terms of, you could say, the use case of making it easy for people to discover and kind of pull things off the shelf, we're still kind of connecting and working on that. But we at least are trying to provide all the hooks so that we can get all the base information about models, like who's building it, what code, what data is it coming from, and then building, tooling and interactions on top to kind of make use of it. But yeah, we don't have rather, there hasn't been a common workflow where a data scientist really wants to find models yet. They mainly want to find data sets. So we've been focusing a bit more on that, but like features.
I was just about to get into that. We're trying to do the reverse problem now because we have all our data scientists that are trying to find new data sets to work on. And it's very difficult, to try and coordinate with our different lines of business and product teams. Where's the interesting data? What's data we haven't seen? So we're trying to build out this same kind of data registry where you can go in, see the different data sets, the schemas, see what features are built out from these data sets, which models they're used in. And that's kind of where we're looking to next. And we found that our data scientists that's where the asks are coming from.
Nice. Feature stores. That wasn't on my list, but that's interesting. Let's see. Model or data. It seems like data is super, what I'm hearing is if you have the right data, your model can be super simple. And so making sure data is in order. Key.
And that's hard because that's a huge dependency on the data infrastructure side of the house. So it depends on the maturity level of that data infrastructure team or in that organization.
Yeah, it goes back to the Occam's razor principle.
Yeah.
We've actually punted on like featurization efforts because they're so difficult. And I think actually getting a handle on what a model is actually helps get a handle on what features are. And so that's where we started. Because invariably you can have a model produce features. And so we think, at least starting with a more constrained kind of view of things, which is just looking at what a model is, then helps us potentially build all the abstractions or things that we need to kind of make reusing models as tables or as data much easier down the road.
That is pretty cool. Yeah, go ahead, sorry.
I was going to add to that. I think Feature Store has two aspects. One is the online feature store, and the other one is the offline feature store as well. So it depends on the needs. Then you figure out where the right focus should be.
Yeah, feature stores has been a big thing on our wish list because we have data scientists that kind of rotate around our different lines of business and touch different data sets. And sometimes we find that, they're spending time recreating the same features. So it'd be very nice, to have this feature store where they can almost plug and play.
Yeah. Maybe jumping ahead a little bit from data to features, and I heard monitoring come up from multiple folks. So maybe let's go there because that's tightly coupled to the data. It seems like you're watching the data, kind of seeing whether that makes sense or not. So before we get into kind of how that relates, maybe just what motivated you guys to build out a monitoring system? And I was looking at some of Cornell's actually answers on the Slack channel what were some of the challenges in gaining adoption and all of that. And it just points to the fact that it's a new area and the benefits of monitoring are unclear. So like for you guys, was there a particular thing anonymized, to whatever degree necessary that was like, all right, this is a forcing function for us to put monitoring, or is it more a best practice that you're trying to bake in?
I think aside from best practice, being in the financial industry, we're very regulated, so we have to.
That's fair.
Yeah, I mean, go ahead,
Stefan. On our end is some of the predictions are really important to the customer experience. For example, the ETA, right? That's our promise to say how long the food will be delivered to the customers. And as you can imagine, during the COVID-19, the whole situation impacted that estimation or prediction a lot. So by having the monitoring in place for that kind of very important prediction or metrics, triggers us to essentially we say you gotta build out our monitoring. It's just one of it, but there's many other things that we gotta monitor that predictions can potentially impact the business and the customer experience.
Yeah.
Got it.
Yeah, monitoring, I want to say it has kind of many layers, especially when we're talking like models, because there's the actual, if you're talking like microservices or online inference, right? There's the usual, latency monitoring, the actual web service or whatever's running it monitoring, and then there's also the data that is coming in monitoring. And so for us at Stitchfix, it was we hire full stack data scientists. We wanted them to have end-to-end ownership. So actually having being able to auto-generate the service means that we can actually stick in like monitoring best practices however we want them, without them having to like actually think what is the best practice. It just comes with it. And so that is helping us, at least from an on-call standpoint, like making sure that everything has the right hooks or the right checks in place. So no service goes out without a PagerDuty attached to it. No service goes out without Lightstep or CloudWatch kind of alerts on it. And so from that we can ensure that there's best practices and things being surfaced from that perspective. And we're currently now working more on the data monitoring side. So how do we get quicker alerts when some predictions are going wonky or bad data is creating bad models?
That's an interesting question that you had asked, because I actually asked a few of my data scientists, because they've been increasingly asking for resources around MLOps. And I asked them, what fascinates you about MLOps? And they told me, that we work so hard to build these models, and we really want them to perform well. And there's so many things that can go wrong, and we want to know. We want to stay up to date with what's going on with our model, and be able to trigger retraining sessions and understand, the drift in our data.
Yep.
That is fascinating. And underlying sort of assumption seems to be that the data scientist is the consumer of the monitoring. Is that accurate in you guys' case? Because there's the APM stack that usually your DevOps engineer or your software engineer is going to handle, and then there's the data monitoring side. In your organizations, is it the data scientist who's actually responsible for, model monitoring, the alerts that come from there? Will they get paged at 2 a.m.?
We do have our data scientist on there.
Nice.
And hopefully they don't get paged, but yes, we all get paged. And we like to have a data scientist just because they're our model experts. Yeah,
we auto-generate the services. So we're on call for service because the data scientist can't change the service that the model is deployed in, but they are on or at least everyone has a PagerDuty, so if we do need to page someone about their model, we can kind of page it. But ideally, with the data monitoring and stuff, we actually push it upstream into before the service is deployed, and then they get notified of failures, before they reach production.
Yeah, for us, would be combinations of data scientists, machine learning engineers, as well as the ML platform engineers.
Did Hien, do all three get paged at the same time, or?
No, it tends to be, depends on what's going on with the model performance or our prediction service. So it depends.
So you brought up indirectly a question that was on my list. There's different roles here with the data scientists, ML engineers. There's increasingly a platform team, which is in service of the data science team and enabling them. What have been good organizational constructs or team structures that you've found across the various companies you worked at? Like, are you seeing the emergence of a platform team? And interesting, two of you are on platform teams, and then there's presumably you guys, your customers are the data scientists, and then Adam here is from the data science side, at least from what I understand. So is that working well? Do you see the platform team eventually just becoming part of engineering, the broader engineering team, or in enterprise companies, kind of IT?
Oh, I see. Yeah, I think for internet companies like us, we are part of an engineering organization. So data scientists have their own separate organization, and there's machine learning engineers are working part of the product engineering. So these are three separate teams, at least at DoorDash. I heard from or reading from various blogs, there's data scientists working with IT. I think in our world, IT doesn't do this kind of things at all. Mostly engineers do.
Yeah, it echoed kind of what Hien said. What's different about Stitch Fix is that, I'm engineering for data science, so my data platform itself is within the algorithms organization. So our sole purpose is to kind of help data scientists work. But essentially, I think the split kind of applies is that we don't have the product engineering component because we expect our data scientists to kind of fulfill it. But I actually think depending on the platform and depending on the model SLA, you could probably just get away with data scientists and a platform or a vendor for models. But if it's really like they need high performance latency stuff, I think you'll invariably have some sort of more specialized a team working on that kind of product to ensure that SLAs are met.
Makes sense. Awesome. I will switch gears to a question that Adam had brought up that links to a previous discussion, which was maybe it was Hien, you brought this up too. It was online learning, retraining, and how does that link to drift and monitoring? Do you need to monitor if you're retraining frequently, and kind of best practices around retraining?
Yeah, I would say it's always a good idea to have some kind of model monitoring in place, regardless if you're doing online learning or you do have these fixed retraining sessions, just so you know what's going on. You may have a fixed retraining session every 3 months, but then maybe 1 month in, we have kind of a black swan event that occurs, which could kind of change the shape of the way our data looks for a little while. So I would say, yeah. For us, we always have some model monitoring.
Yeah, I think model retraining, it's at a high level, it's a great idea, right? Because you want to retrain with the latest data, so the model will perform better and such. I generally agree with that. However, there's a cost associated with model retraining. And depending on the maturity of your infrastructure, how much time that will take the data scientists away from doing their new model development for them. And the other aspect that's interesting is not all models are the same. So therefore, certain model has very critical impact to the business. So you want to be really careful about deploying a new version of your model as well. Because if something went wrong, you got to spend time debugging that. So there's nuances about that. That's quite interesting, depending on the use cases in the company.
Yeah. I think it's somewhat context dependent. So yeah, definitely if it takes a day to train your model, you're probably not going to be training it each day because it's probably going to cost you a lot. Luckily, I guess at Stitch Fix, pretty much every model that gets to production essentially is retrained daily or at least weekly. And so getting to production actually means they've produced a workflow, an ETL that is set on a cron that retrains their model. Like that's essentially kind of the expectations we have at Stitch Fix. Now we can get away with that just because yes, the models don't necessarily take all that long to train, and we have continuous structured data flowing in. So there isn't so it's really easy to set up kind of expectations on tables and for them to be updated, and people to set up ETLs that way. But that at least has enabled us to kind of skirt most of the issue of reproducibility, or if someone leaves, their model still keeps retraining because they've set up that cron. No one has to really do anything. It's not like, oh, it's been 2 months since that model was retrained and we have no idea how. So luckily we've, you could say, culturally engineered to have that expectation that data scientists, to get to production, they need to have an ETL that they can set on a cron to retrain things.
That's a really good point of reusability, and to handle situations like what Stefan said was data scientists left the company. I still hear story where, a data scientist left the company and nobody knows how to retrain that particular model. So we definitely want to get better than that.
Yes, or you waste a lot of time redoing work, which is what I did at some point. It's just, you spend months to discover that someone had done what you were trying to do. Not fun. That's awesome. All right, so that's on the retraining side. A related point is on model testing, which I think also goes to monitoring a little bit. In software, we do all kinds of testing, unit tests, integration tests, you name it. Models kind of sorely lacking. So what is you folks' philosophy around that? And does it tie to monitoring, or how do you think about that?
I think coming from... Oh, go ahead.
To be frank, that's an area that we really need to get better in terms of model testing. We do recognize that it's important. We have limited capability to do that at the moment. There's a whole concept of model score, right? There's a paper from Google, I think, that talks about how to assign a score to a model while going through all these kind of unit testing, if you will. But it's, I think that's a goal we want to get to, but it's not that easy, at least for us anyway. So I'd love to learn from Stefan and Adams in terms of how they do that.
Yeah, for us, kind of coming from the financial world, anytime we deploy a new model, we like to test it with our banks. So if we build kind of a restricted API, or if we build some dashboard that integrates with some model results, we like to put it in their hands, for a couple months, let them feel it out, see if it's suiting their needs, before we kind of run it through a full production environment.
So testing for us, I think, is, assuming people back test their model, then, they could be confident, but really that the model that they push, and we have an online A/B testing system to kind of, check for that. But really, the errors that really pop up are, should this model be deployed in the first place? Because if they set the cron and they're not paying attention to their workflow, and somehow there was no data for one of, say, the SQL commands, and the model is kind of crap, that historically has been on a per data scientist basis, as to figure out what to do when. With kind of the setup that we have, we now have the facility to encourage people to add a QA step to the model. So check the model metrics. We can programmatically, if you store metrics associated with the model, you can have a check to only update a tag if this metric is, say, over a certain value, so that it's good to be deployed to production. We've had instances where people have deployed the development model by accident just because they use the same namespace as the other model. So I think part of the solutions here is actually coming up with the CI/CD system and what checks and balances you really kind of put in there, and that kind of really, I think, depends on what company you're at and as to what's kind of required.
100%. We've seen people use golden data sets for that purpose, as you were mentioning, kind of what is the value. I think CI/CD generally for ML could do with a lot of just fleshing out, because CI here is so different from CD can kind of be turn the crank, but testing kind of very open. That makes sense. A related question on monitoring observability, folks are using those terms interchangeably. There's also explainability, which seems to get, integrated there somewhere. How do you think about those terms, and what do they mean to you?
Yeah, that should go first. I think his domain needs a lot of that. Adam, go ahead.
From our standpoint, it really boils down to the use case. Being in the financial industry, there are severity of use cases. Things that will affect somebody's lives. Maybe doing some clustering to try and figure out, what market or segment somebody is in is a lot different than a risk use case where you're trying to do things, involving credit scoring and use cases like that. So it really boils down to the use case for us, how interpretable or explainable our models need to be.
Yeah, the explainability side, I think, is from a product standpoint of if you have a recommendation system, that's where I think explainability actually comes in, because a model is potentially just a piece of a recommendation system. So that's where we try to have some tooling to help kind of explain the funnel of a recommendation system. But on the model itself, this is where observability, our mind kind of goes to like feature importance. And really, that's currently, model-based and data scientist-based, since depending on the model, you can get, observability or introspection on feature importance easier than others. And so it's really something that I think they use to create better models, but we don't actually use it too much in a production way for alerting or anything just like that yet.
Yeah, in our area, explainability has become an important topic, but not as important as other ones at the moment. But data scientists do want to know like the feature importance, like Stefan was saying, and there's quite a number of open source tooling that are out there that we are investigating to integrate into our platform. So at least data scientists, if they would like to, they can spend time looking into those. So yeah, that's where we are on that part.
Makes sense. And I'll piggyback a question on that. But for the audience, we're about 15 minutes out from wrapping up the session. So if you have questions, do put them on Slack or send them in the Q&A, and I will start picking them off in just a few minutes here. All right. But in the meanwhile, maybe future facing, Hien, you mentioned that explainability wasn't the key one right now, but maybe in the future, what are the things that the three of you are looking to solve in the next 6 months? What are topics that you would like to highlight to the broader community as kind of deserving of more attention and discussion?
For us, so far we've been seeing a lot of use cases that are based on numerical features, but increasingly we're starting to see use cases in the realms of image classifications, NLPs, and the other part that we really want to tackle is end-to-end feature engineering, that hiding all the complexities and all that good stuff with large amount of data. For special instruction recommendations. So those are some of the big things that we're working on for the next 6 months to a year.
Yeah, I think from our perspective, it's data quality, because data is really the food for these models. And I think we've seen a lot of research, around different model architectures, some a lot more advanced than others. And I think, looking at kind of the natural language processing, it's almost like a space race for parameters. But for us, I think we really want to focus on data quality, have, high quality data sets that our data scientists can use, make sure everything, in our databases is kind of architected properly, and have just, great data sets where we maybe don't have to use the most advanced model. So yeah, just collecting, nice, good, high quality data.
Yeah, it's a similar theme. So like I like the ingredients analogy. So yeah, we're looking at what I term centralized featurization. So how can we not only provide a feature store abstraction, but then also work on the end-to-end feature creation, and how much of that can we orchestrate versus the data scientists having to do that. And then, but then we want to couple it also with kind of data monitoring and data observability efforts. So how do we, check the quality of these things over time? How do we ensure that, the data that's being fed at production time is the one that's the same as being, trained on? So how do we build more kind of hooks and tools to kind of just enable that more broadly? Is kind of where we're looking to go.
Awesome. All right, I'm going to start taking questions from the audience as well, and I have a few others that we can touch upon depending on time. There is a question on feature stores, and I'll just broaden the question. The questions around feature store, that's part of GCP, but I'll just expand that to vendor feature stores versus feature stores built in-house, and how you folks think about that. And if you could extend that not just to feature stores, but ML platform, that'd be great.
Sure. For us, our feature store, at least the online feature store, is based on well, we like to say built in-house, but it's based on Redis, based on Elasticache on AWS. So we put infrastructures around that in terms of uploading them, building the very efficient data structure, because we're storing billions and billions of features. So therefore, how do we make sure that it's very efficient in terms of memory, in terms of access, and all that stuff?
Yeah, from our side, we're more of an Azure shop, and we're big Databricks users. And I know from Databricks World, they just announced a new feature store integration with Databricks. So that's something we've been very eager to try out from our side.
Yeah, so it's Stitch Fix is a decade old. We grew up with in-house kind of feature store solutions. So I think we had like 3 or 4 over the course of our lifetime. I think we currently have like two or three running in production still, 2 different systems. And so, had we be starting things today, maybe we would use something more off the shelf, but largely like we've been getting away with something like starting off with Postgres or one of the Aurora offerings on AWS, but it looks like DynamoDB is kind of our newer one, or at least one of the new ones that we're seeing people go towards. If you look at what open source is doing, there's a lot of movement around Redis, and so that's also something we've seen people go towards. But I think the tricky part with the feature stores is the online technology is kind of commodity. It's really how do you connect it with your offline that I think is where some of the synergy actually comes from. So how do you ensure that things are an offline are also an online when they need to be, and then to handle the streaming case is the other one. So how do you ensure that the features that come in from streaming and from batch match? So there's like there's a bunch of ways to do and tackle that, and it really kind of depends on your context. But there is a lot of options, and so I understand that naturally this is a question people want to know more about.
Makes sense. Another one, which is also feature facing, do you see data science and software engineering coming together? Do you see data science or ML specializing and focusing on the statistics, and the platform teams really doing the software engineering? How do you see this play out?
It's a tough question.
So selfishly, for my team's sake, we expect the data scientists to be end-to-end responsible. So we want to give them the autonomy, but we don't want to own the model or the business context. We want to provide them the tools so they don't have to engineer the connection parts to production. So in some sense, the answer is yes, except to both of those, that data scientists do more modeling and statistical stuff. Well, that's the code that they write, and everything else can be taken care of, but they're still in full control. Like, I don't need to be involved for them to get something to production. They just need to use my tools. So that's where I hope things are going.
Sam here, I think also the other dimension is the expertise of each of these teams, right? Their specialty, their focus is, I believe, is different. So for a team to scale and grow, I think you need those level of expertise. Data scientists are great at what they do. Software engineers are great at what they do, and they're very different for different problems. So.
Makes sense. Maybe another one around teams and team sizes. So how have you seen solutions or problems change based on the data science team size that you're serving, and how has that impacted your development?
For some of the use cases we work on, we like to call it a 2-pizza team. So a team size that's just enough where you would only need to order 2 pizzas. And we found that that's kind of a good combination for us for the number of data scientists working on a problem.
I mean, I do think there is, depending on your team size. Like, so once you have multiple teams, 2 pizza teams, right, you do get different problems than you did with just one. So I do think there are different, off-the-shelf solutions definitely help target those teams to be more, productive than the other. I mean, at Citrix, we have a lot of two-pizza teams, in which case we have, it's very important that we have a flexible, model tagging kind of system. Having a hierarchical one which rolls up to a single person it controls, it just makes introspection and visibility kind of difficult. So I do think there are different nuances to at what scale you're at. So, but for most people, I think, who aren't at tech companies with large data science teams, I think the majority of what's out there is probably suffices for you.
At DoorDash, we use a embedded model, and probably some other companies are doing the same thing, where it's a centralized data scientist team or organization, but those data scientists are embedded into the various product teams. And in regarding supporting, so I think obviously the more data scientists there are, there's going to be bigger needs for the platform team to be able to support that. Obviously, we're trying to build all the automations as much as possible, but the increased support is still going to be there, considering less new data scientists are joining a high growth company.
Got it. Awesome. Thank you. I think we're almost at the end, so maybe let me just open it up to you three. If there's something that we haven't covered you want to highlight about MLOps, would love to hear that before we wrap.
For me, I think we'll be hiring the folks that are really passionate about this area. There's a small segment of engineers that are interested in this space. So hiring is a continued challenge. There are a certain group of people in this, but it's getting increasingly challenging.
And could you talk a bit more about that? Like, I'm curious, is it because it requires data expertise, software expertise? Like, what's the ideal person that you're looking for? I think it might apply across the three of you potentially.
I would say a mixtures of interests and knowledge in the realms of data engineering, software engineering, and some passion about machine learning.
Yeah, I find part of the, echo Hien's comment, it's hard to hire for machine learning platform roles because there are a lot of people who want to build models because that's the hot cool thing. They don't particularly want to spend time on the infrastructure. And so that has been, slightly difficult. And I want to say if anyone who's built models, you probably have and are good at software engineering and at data engineering, you'd make a great candidate for, someone on ML platform because at least at Citrix, we don't have product managers. So my team, we kind of product manage our own stuff. So having someone who can empathize and kind of think about, ideal product experiences definitely helps a lot and steer people into like being more autonomous. But otherwise on the software engineering side, there are people who, their interest is data engineering. That's all they want to do. They don't really care for that stuff. So that is, hard to hire.
Got it. So if you're listening in and you're interested in ML, data, and software, which is probably why you're here, get in touch with these folks. Adam, any final thoughts you want to add before we wrap?
Yeah, no, it made me think back. I talk to students all the time, and they're always asking, for career advice. And they're like, what are some things we don't get to learn in school? The things I tell them that, when you get in the real world, the data is not like the data you do in you use in your projects. That's nice and clean and ready for you. But then also, you don't really get to operationalize or productize models in school. Like you don't get to learn as much about MLOps behind the scenes. And that's something, that I always tell them is super important. Focus on, the model architecture, understanding what they do, stay up to date with libraries, but learn more about MLOps because it's very, very important to organizations.
Wonderful. Thank you so much. That was great. I'm glad to see more and more people, hopefully with events like these and others, getting excited about MLOps, and we'll have a growing community there. So with that, let me wrap things up. Really appreciate all of your time for this panel and previously to all of the speakers as well. The recordings will be available after. Do check them out. Feel free to reach out to any of the speakers who have listed their contact info or reach out to us and we can make an introduction. And of course, everyone's on Slack. So thank you all. This was great. And we'll see you soon at the next MLOps.
Thank you, guys.
Great.
Thanks,
Thank
Manasi.
you.
Thanks, everyone.
Bye.
Bye, guys.